Hey, continuing from the previous video, I stopped at expanding logs, getting back to condensing logs. So look at the first example, it says, hey, condense or write it as single log, which is another indication to be using the properties from right to left. Let me show you the properties again. These are the properties we talked about. So one more time, when you're going from left to right side, we are expanding them, and then vice versa. So this is going backwards. All right, when I look at the first one here, this is a minus sign, so that reminds me of the quotient property because quotient property expands to a subtraction expression. However, this 3 can also be brought back as the power of x. So the first step would be to compress the 3 natural log x to the third. And now this is subtraction, can combine them as long as both of them are natural base, which means same base. We can apply these properties. So numerator over denominator using the quotient property. And what did the property say? It said log of any base m minus log of the same base with another expression can be compressed to log base a m over n, and that's what I have used here. All right, looking at the second one, this is 3 terms, so you can only go left to right. If you look at the first 2 terms, this is the product property, which said that if you have log m base a plus log n base a, that could be compressed into a single log of m times n, so the same base. So this is my m here, and this reflects the n here. I'm going to compress it, log of m times n to base 5 minus log of x plus 1 base 5. This now looks like the subtraction property, which can be compressed into quotient, log 5, 7x squared over x plus 1. And I compressed it to the best I could. All right, that's a couple of examples of condensing or writing as single log. Actually, I have a third example here. This is a very good example as well. Condensing. First of all this is under the log sign. So the natural log of 5 squared minus 1, it's numbers, so it's best to just combine them. 5 squared minus 1 is 24. This can go and be the power of 8. So 8 raised to the power of 2/3. So far, this is where we're at. Minus natural log of 24. Now, 8 to the power of 2/3 is 4. How did that happen? A couple of ways. 8 can be written as 2 to the third power. And we already have 2/3 there, which you can cancel the 3's, 2 to the second is 4. Or I could also write this as 8 1/3 squared. Now 8 1/3 is cube root, and cube root of 8 is 2, and the squared, which is 4. So back to 4, which means this is natural log of 4 minus natural log of 24. And I can compress this into a single log as a quotient. Obviously that's 24. Now 4 24ths can be simplified, so we have natural log of 1 over 6. It looks like it is compressed all the way, but this is a very interesting problem because if I expand it back to log of m or minus log of n, natural log of 1 is 0. In fact, log of any 1 is 0, no matter what the base is, because whatever the base is, like whatever it is, and I didn't mean to put a circle, but whatever the base is, raised to what power will get me 1 has to be 0. So this is 0 minus natural log of 6, which is simply negative of natural log of 6. And these were the 3 examples for condensing. All right. These are pretty good exercises. Like you can put down your pencils and kind of try and see if these have been done correctly or not, so true and false type. We're looking at number A, natural log of x plus 2. Can it be expanded as natural log of 2 plus natural log of x? That is not true. That is false, because for this to work, this should have been a product, so 2x. If this was 2x, I could have separated it as log of 2 plus natural log of x. Since that's not the case, this is applied incorrectly, a very common mistake, so watch out for this. I'm jumping to C. This is quotient, so this should have been expanded as log of x minus log of 4, which is not the case here. That's false as well. Looking at e, which can also be expanded as log of 10 minus log of x. But what happens is log of 10 is 1, and hence this works, it's true. b, now this is product, this is your m, and this is n. So we should be able to apply a product property to it, which says log of the first, log of m base 3 plus log of n base 3. So this is totally good to go. Looking at D, this 5 can be brought down here, and that's exactly what they did. And you can, I'm going fast, but you can always go slow, pause, think about it, and then go from there. If I were working on F, this is also product. It's product of 49 and x squared, so I should be able to apply product property, log of 49 base 7 plus log of x squared base 7. Now log of 49 base 7 is simply 2. Because 7 to the second power is 49, so that works. Plus, this 2 can be brought down here to 2 log x base 7. And it can be expanded like this, and that's exactly what they had. So this is true. This is true, it works. Last one here, is this expanded correctly? Well, there are a couple of ways to look at it. Number one, this 3 could have been brought down here, so if I had 3 times log of x, I would have called it true, but I don't see that. The other way is x to the third power basically means x times x times x. So I have product of 3 expressions, which means I should be able to use product property, which said log of m plus log of n plus log of, property didn't say m, property said mn and didn't go beyond, but as long as it's product, you can apply it to as many terms. So, or else I should have had this, but I don't have either of those, neither this nor that. This is totally different from any of these. So that's false. However, if there was a plus sign here, it would have been true, if that makes sense. All right, moving on. We're still on that last topic. We're solving logs using properties. It may look like it's all over the place, but that's how it is. Those properties can be applied in several ways, and several things could be done with logs. If I look at this slide here, this question is saying convert these given expressions to only natural logs. Natural log means ln, so base e. The thing with conversion is I'm going to use the change of base formula, which we went over earlier. Let me remind you what it said. It said log of b to any base. You could change the base and rewrite it as log of b over log of a. Now I have defaulted use base 10 here because I didn't write any base. But this ratio will be the same no matter what base you use. If they say change it to common base 6, this would still, the ratio would still be the same, just change it to base 6. If they say change it to natural log, they're basically asking me log of b divided by log of a, but they're saying we want base, natural base, so we want e. But we know we don't write log base e like that, so you can write it as log b over natural log b over natural log a. All these ratios are the exact same, so it does not matter what base we pick as long as we pick the same base. So I could write this as log of x over log of 2, totally fine, but they were very specific, use natural log only. I'm like, sure, just change that to natural log. The ratio will still be the same. And I'm done. I rewrote it as natural log. This one here, default base is 10. So I could write log of x plus 7 over log of 10, but they wanted me to write natural log. I'm like, sure, just write it natural log. Natural log of that over natural log of 10. Similar to this, natural log of 80, I think that's a 9 over natural log of 3. As long as you keep both the logs the same, ratios work. This one says common logs, which if you remember, that is defaulted to base 10. So I'm like, sure, log of x over log of 2. It is common base 10, common logs. This would be, that's natural log. So there's e here, which means natural log, but they want common logs. So log of x, y over log of e. They wanted common log, which is base 10, so I kept it as base 10. But again, we won't write base 10. I know this was this was also kind of random, but change of base is kind of convenient because you can change the base to whatever you want to, as long as you keep it the same base. All right, I think this is my last slide, and these are a bunch of problems. Find the exact value of each expression. Do not use calculator, which means more properties. Solve it. All right, number 13. Log the base and the number here are the same. So this is asking me basically, it's asking me 3 to what power will equal 3 to the power of 71? Well, obviously 71, so done. 14 log base 2, and again, that number is the same. If you use it like long enough, if you do a lot of problems that are very similar where the base and the number here are the same, the answer literally boils down to just the exponent. 15 natural log e, there, right there. It's a natural log, so the base is defaulted to e. So this is the exact same problem like 13 and 14, except the base is e. This is base is 2 and 2, base is 3 and 3. So you could simply just ignore this, and the answer has to be -4. Okay, 16 natural log e raised to the power of √2. Again, remember, base is e here. So the base here and the number here are the same. Answer is simply √2. It looks like I've picked a lot of similar ones. 2, log is in the power with the same base, 7. So when the number here and the base of the log is the same, well, the answer, everything drops and the answer is 7. E raised to the power of natural log 8. If you notice, the number here and this is again the same. 17 and 18 are exactly the same. The answer will boil down to 8, just using the property. 19 log 8, 2 plus log 8, 4. Good thing is the bases are the same, and there's addition here, which means I should be able to compress it to m times n. That compresses to log base 8 of 8, which is simply 1. Like 8 raised to the power of 1 will be back to 8. Okay, and one more, just 20. Log base 6, 9 plus log base 6 of 4. Base is the same, and there's addition here. We should be able to compress it to product property. Log 6, 9 times 4 is 36, which should be 2 because 6 squared is 36. Okay, looks like I've done them all. Oh yeah, there's one more here sitting here. Let's call it 21. That's the last one. This is very interesting too. There's multiplication here. Also notice how both the bases are different. That's a different type of problem. I cannot use a property directly here on both of them together. I have to treat them separate with a multiplication sign in between. Now this, I could use change of base on the left side times change of base on the right side. Now notice how these two cancel. That boils down to log of 9 over log of 3. This is a unique problem. If you're looking at it for the first time, you wouldn't know what to do. Like you were probably thinking that I wouldn't know what to do. It's just a matter of practice. And then log 9 can be written as 3 squared. And please don't be canceling these out. That's not how it works. I could use the power property here, bring down the 2 in the front. Again, I can't cancel the 3's by themselves. I can't cancel the logs by themselves because they're connected. But because these two are the exact same, whatever their value is, I don't care what the value is to log 3, but whatever the value is, there's going to be exact similar value at the bottom. The values will cancel, the final answer being 2. Alrighty, I shall wrap this up here. I know that was a lot. It is what it is. Practice, practice, and practice. All right.